So, what do you think of when you think about old video games? I personally think about Atari, but more specifically Pong. This video is about recreating Pong. I am a computer science student, and I had to make a class project in my Java class this last semester. So, my teammates and I decided to make Pong. Since we had never made a game before, we thought starting with one of the first video games would be a great place to start. What we didn't realize that this would be a much more complicated undertaking than we ever expected. Of course, any experienced programmer would have been able to do this project much better and much faster than we did, but this video is just here to help out the beginners like me and my teammates. In this video, I'll be showing you the Pong program that we created, as well as showing you how we made the code and how it all works and how it all links together to create this coherent game that you see before you. Before the video starts though, I do need to say that we did not figure this all out on our own. We actually used a lot of help from the internet and a blog run by a guy named Jad Bodnar. We followed his tutorial for a breakout style game and modified it to play Pong instead. I will be providing the link below in the description for you to be able to look at the blog and see how we modified it. I'll probably explain in the video as well. But anyways, let's get into the game, show you how it works. So, welcome. This is the IDE that I use to develop Pong, and this is NetBeans version 8.2. This is what we used in class to develop the program, and that's just what I stuck with and what works with this program. So if you have errors or anything happening, you try to look at this code and try it for yourself, you need to check the NetBeans version that you were using. But it shouldn't mess anything up too much. So I'm going to show you how the game plays and just how it looks and stuff. So I just show you how exactly it works. So this is all the code. These are all the different files and stuff. And I will go through all of these individually after I show you the game. So this runs from menu.java. We have a very simplistic menu that shows up on the screen. It has the name of the game, Pong, and it has the instructions on how to play. It tells player 1 that W and S move up and down, respectively, and player 2, the up and down arrows, obviously, move up and down. So, yeah, and then, of course, we have the start game button that then goes into, it starts the program and makes it go. So, here we go. So, as you can see, we have a very, very simplistic graphical interface. Just 3 rectangles is all that the screen is made up of. All the stuff that moves is just 3 rectangles anyways. Of course, the ball is a square, which is still technically a rectangle. We also have 2 strings, or font, whatever you want to call them, up at the top. Those were put there using int2string methods, so that we just change a variable and then it automatically refreshes every time it redraws. So now that I've shown you how the game works, now I can start to explain some of the files themselves and the programming and all of that and how that works. So I'm going to start with the most simple file that there is, that being commons. This file just holds some static values that basically just stuff that we know we're going to need and don't want to have accidentally change or have different versions throughout all the different files. So all of the files that need these values will implement it in their public class initiation. So ball needs to know some things, board needs to know, menu does not need to know, paddle does, paddle W also does, Pong does not, Sprite does not. So if you'll notice, well, you'll notice later that paddle, paddle W, ball, and board, all of those need to know X and Y values of where things are on the screen. And since X and Y values are linked to the limits, these are the limits of how far the X value can go, and that is the limit to how far the Y value can go. And of course it needs the left edge and right edge value. This is the value where the ball scores. That's what that value is. this is the value of how wide the window is, how tall the window is. And of course, here's the paddle, the initial paddle location, initial second paddle location, initial ball location, and then the delay and period of the timer we use to refresh the drawing on the screen. So that's what's inside of Commons. The next most simple thing to start off with would be the Sprite. No, wait, would it be Sprite? It would be Pong. Very simple here. So, although it's not completely done, we have public Pong that runs, and then we have it runs init UI. There we go. But yeah, it has init UI, and within that, it has add new board, which means it creates a new board value here, new board class. It sets the title to Pong, and then it tells it to set default close on operation, exit on close, set size to the width and the height. So to access those values that we have in Commons, we need to do Commons dot and then the value that we want. Then set location relative to null means that the screen will center itself for the most part. Then also set resizable false means that the screen cannot be resized. That one explains itself well. Now, something else we need to explain. Oh, menu. Menu is very simple. It looks a lot more complicated than the rest. It has just about 165 lines of code. But that's because we use the design function that's built into NetBeans, which is very nice for GUI applications. You can just drag over a button, drag over some labels and everything, and it'll create it for you and code it all. And then we have here private void JStart action performed. So in here we have something called death mode, which never actually got implemented, but that might be for a future video. We might implement that if this gets a decent amount of views. I can probably implement death mode and I can explain it. But just for now, all you know is that there is a death mode that we plan to implement but could not finish before the project was due. So here you'll notice we have something very similar to Pong.java, which is very interesting. We have add new board, set title Pong, all of this, set size, set location relative to, set resizable. The one thing we have different is Pong game equals new Pong, game.setVisible. That's different. We did not have that here. We had to have that here because Pong, you need to initialize it to create some certain things. Menu, essentially we used to run from Pong.java, that's where we used to run the program. But now menu has the main function, and so we run from there rather instead. So look for it. It should be somewhere. Yeah, here we go. Public static main. It creates a whole bunch of things. It runs. Of course, this was all created by NetBeans. We did not code that ourselves. Here, though, we did. We created this part. Create new menu and set visible true. Actually, no, I don't think we created this either. Ignore that last statement. But yeah, so we have all this Pong game. It creates a new version of this. Then that's the game. So we know how everything was created. Now we know that when the game starts, we create a board. So let's go to the board. This is the most complicated file out of all of our files. This has a ton of values, and this is where most things are calculated in terms of how the game runs. So here we have a timer. Of course, we need timers, we need strings. This is the message. This is the value that we use for the winning message. So when player 1 or player 2 wins, pops up on the screen, this is the value that changes and then is written to the screen. Then we create a ball, which then goes to the ball.java file and initializes all the values there. Then we have a new paddle, which goes to paddle, which then creates that. And then we have paddle W, which then also goes there. Now the reason why we did paddle and paddle W is because there's a certain way that we have our keystrokes and key adapter set up that makes it so that it was just easier for us to create two separate class files. But as a challenge, I could, and for those of you who want to figure out how to make cleaner code, which is something I want to do too, I can do a future video on this and make and show you how to create merge paddle and paddle W into one class so that you can have just one file. So it's nice and clean and you don't have too much clutter inside of your file. Because saving space is a very important thing when making a game. It's very important in the original Pong because they had a very small amount of memory. They did not have any memory whatsoever. We also have a Boolean, which says if it's in the game or not. We also have the score and score W, which are the two score values which print onto the screen. And we have the win condition, which is how many score you need to get to win and pop up the winning text. And we have a value called mod, which is really fun, and I will explain later. So when board is created, when board's called in here, when it says add new board, it calls this function right here, which is init board. And so then it goes through here, and then since board is called, it goes through all of it, and it creates everything. But it starts here, so init board, add key listener. This is very important. This is a special kind of key listener, which is used with TA adapter, which is actually I don't fully understand how it works myself. Again, check out that blog that is in the description because that was very, very large help when making this. Then we have set focusable true. See, one thing I do know is that with key listeners, the object that moves needs to be focused on, and in terms of being focused on, it means it needs to be clicked on by the mouse. So when a window is clicked on, it knows that it is in the foreground and not in the background. So if it would be weird if you pressed up on the arrow key and or you press space while you're inside of a game and you had a Google Chrome window in the background and the video you started playing on YouTube started playing even though you hit the space key for the game and not Chrome, right? So it needs to be able to be focused on so that it knows that it is the one being controlled and not another program. Here we create a timer, which we use to refresh the screen and draw it. So this is essentially what creates the frame rate. So we have the delay and then the period. So the period is how much time is spent. We have an add notify. This is an essential function. Forgot why it's essential. I'll probably edit it and post and figure out why it's essential. Game init, here we go. We create a new ball, new paddle, and new paddle W, which we also did in menu. No, wait, we didn't do that in menu, did we? This is important. We need this. Yeah, we did up here. Yeah, right. So we okay, here. Yeah, private ball is the new name. So then we say ball is new ball. So we can have multiple balls, and this is where we would merge paddle into paddle W. So that's how we would do that. Instead of calling paddle equals new paddle and paddle W equals new paddle W, we have paddle equals new paddle, paddle W equals new paddle. So instead we would just get rid of this W and it would call. Here is a very important part, the paint component. This is what draws things on the screen. So super.paint component G, this overwrites the GUI so that we can set stuff. So we set the background to black, and then here is a little thing where it's a for loop that we used, and this creates the dots down the middle of the screen. So we have g.setColor light gray because there are light gray dots. G.fillRect commons.width divided by 2, which means and this actually means that the things are not actually fully straight because I'll explain that. But commons.width divided by 2, which means the x value is exactly center. So the x value it is drawing at is exactly center. Then we have I, which represents our y value. So if you notice at the top of the for loop, we have I equals 0, I is less than 750, I plus equals 40. So every time this program runs, it's getting added 40 pixels. So it's going down 40 y values. And then we have 10 and 15, which is 10 is the width, 15 is the height in pixels. So those couple lines of code adds the dots. Now we have graphics 2D, which allows us to use fonts. So we have font, new font, dialog font, bold 45. Dialog is our font that we chose to use. We didn't have time to make the blocky text. That would mean a lot of rectangle drawing and a lot of figuring out how to change how it looks. So here we have set color white, set font, which is this, calls this. Drawstring, integer.toString score, comments.width divided by 4 and 100. So this is the line that draws the score on the left side of the screen and tells us how much score the first player has. So that's simple, and then we do the same exact thing. And technically we don't need to add these two because this is already set, but we did just in case. We have a drawstring, but instead of using score as our variable that does integer.toString, we have score w. And to make it on the other side of the screen, we subtracted comments.width divided by 4 from the actual width to make it exactly the same distance away as this value. Because comments.width times 3 divided by 4 would not exactly be the same as this, although it might be. I could be entirely wrong in saying that. I'm supposed to be really good at math. I'm okay. You could also do comments.width times 3 divided by 4. I think that would work. But comments.width times 3 would need to be in parentheses. Otherwise it's... Oh no, you could do times... Okay, never mind. Yeah, you could do that. Ignore me. If in game, so this is our game loop, as you might want to say. If we're in the game when this function is called, then we will draw everything. Now we don't see this yet. This has not been called. It's not been created up here. It calls this function down here, which is the game loop for the things that move, which is the important part. Now we have a game finished. If the game is finished, then it will stop drawing. Which is down here. This tells us who wins. So draw objects, set color white. So all of these are white colored. And here we create a rectangle of the ball with ball.getX, ball.getY, ball.getWidth, ball.getHeight. The x and y will be changed by other functions lower in this program. And same thing with the paddle and paddle W. So this is refreshing every, you could say 60 times every second, just about that. And using paddlew.getX, it is figuring out where it is and then drawing it on the screen every time this is called. Then we have game finished, which is our win condition, which lets us know who won and which player won, essentially. So we have drawstring message, and message is, so here we have a little smart stuff. We have meter.stringWidth message divided by 2, which sets it perfectly in the middle of the screen. That's a little special function that I could talk about all on my own. It's a font metrics up here. It's this .get font metrics of the font. So it's basically telling us how long each character is. So we get to know how long the message is in terms of pixels, which is really cool. This returns a integer right here, because we can do math with it. So here is the important part. This is the tough part, and this is the part that I suggest you read the blog all about, because it really helps. But I'm going to help you a little bit. So we have TA adapter extends key adapter, which is what we use to interpret when buttons are pressed on the keyboard. So here, if we have key released, which means you have let go of a key, then it calls both, and this is universal, so no matter what key you release, it checks, it sends this to paddle and paddle W. So they both have functions inside of them called key released. And the key event is, the key event E records which key is pressed in a value. So we send that value to both of those. And same thing with key pressed. So whenever we press a key, it sends the key that was pressed to both and figures out which one is doing which. Now here we have the the this is the actual game loop. This is the timer looping, and this is all the functions that it calls when it's running. All we have is move, 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 check collision, and repaint. Repaint will call paint component. It's a shorthand to call paint component. Then it does all this, which then calls draw objects, which then does this. So this line of code right here, this single line of code, calls all that right there. Actually, technically this too. It calls all of that. So that's fun. Now here we have this is completely ours that we created. This is a function called score that tells us what things to do. So mod is changed to 0, and I'll let you know why it does that in a bit. It resets the ball to the initial position. We cancel the timer, and then we create a new timer so that the ball doesn't immediately start moving, because initially we didn't cancel the timer, and you would have to react very, very fast to get back to where you're going. We also changed the direction of the ball so that it's going straight and it's not going in wacky directions the moment you reset. So you know exactly where to go, and it's your ball to be able to hit. Basically balance. And then if the score value is the same as win, then in-game equals false. We cancel the timer and we set message. So this is where we set the message. And then when that message is set, game finished, we'll draw it. Now in score W, we have the exact same thing, except we use a different value called score W. So this is called whenever something is scored. So whenever something goes past the edges. So score W is added +1, and then that'll also cause something to change. Stop game. This function is deprecated. We don't actually use it. Here we have check collision, which is a very important thing, and it's really, really long. It's the last thing in this file. This is super important though. Nothing would work without this. So we have if ball.getRect.getMaxX is greater than commons.writeEdge. So just understand what that means. So here, ball.getRect is it's fun to say getRect. That means it's getting the values of what the rectangle is. So it's returning 4 values. It's returning the x, y, width, and height. So here it's getting all those 4 values, but then get max x. So it's then finding the x value that is the maximum. So it's basically, in this case, most rectangles are, the center is not actually the center. The center is the top left corner of all rectangles in this, in Java. And so it's getting the max x by adding the width to the x. And so it's checking if so get max x means it's checking the right edge. If the right edge is past the commons.writeEdge, then we're going to score. But if the ball's left edge, get max x. Actually, I think this makes our game a little bit harder for the player on the left. It might just. See, if we want, so this is getting the max x, we want min x. So you get to see some creation right here in front of you. So getting min x means it's checking the left edge. And then if it's past the left edge, then it's going to score. So up until now, the player on the right side had an advantage over the player on the left side. But that was just fixed. That's what you call a patch. Now, if ball.getRect intersects paddle.getRect. This is the most important part of the game. Without that if statement right there, the ball would not bounce off of the paddle. That's simple as it is. So it's checking the getRect and checking if it intersects any of the values. This is a very complicated function and is very, very important. We were glad we were able to use it. We didn't implement that. That is actually part of this whole thing. And so if it's intersecting this at all, If this rectangle is intersecting that rectangle, then it's hitting. So here we have mod. Now you've probably noticed if you saw a little bit of the gameplay, but the mod value is actually a value that is increased every time the paddle is hit. The ball hits the paddle. And this, it controls the speed of the ball. So the game is not too easy the whole game, and it slowly gets harder and harder and harder, and eventually a player will win. There's actually a glitch that comes with this, which I will explain at the end. So here we have paddle left position. Is paddle.getRect.getMinY. Then paddle left, or ball left position. Ball.getRect.getMinY plus 10, because we want the middle of the ball for these calculations. So because half of the width, or half of, it's a square, so half of the width or the height is 10. Here we have a sophisticated, or not sophisticated depending on your perspective, version of how to choose where the ball goes. So if ball L position is less than first is up here, paddle L position plus 20. That means there is a 20 pixel gap from the top. So getting mid Y means it's getting the top of the paddle. And then that plus 20, so it's creating a little area itself that is 20 pixels high from the top of the paddle to 20 pixels down. And that creates a little section that we use here to choose that the ball will go off at a 45-degree angle. So this one is going off at a 45-degree angle upwards. This is bouncing off of the right paddle. And so then here is where we also add mod. So we have ball.set x direction and set y direction, which are functions inside of ball, which I will go over in a little bit. But it's -2 minus mod, -2 minus mod. So this is going off in a 45-degree angle to the top left, and it's increasing as mod is increasing. Of course, then we have second, which is actually only a 15 pixel gap. We have third, which then is only a 10 pixel gap. Actually, no. Second is a 25 pixel gap. Yeah, okay. And then third is also a third actually. So these four values split the paddle into 5 sections. So it's interesting. You have to think of it as like a table. So if there's 4 lines in a table, there's actually 5 sections you can put values into. And so the first one at the top is 20 pixels, then 25 pixels, then there's a middle one that's only 10 pixels wide, then there's another 25 pixel value, and then another 20. So the 10 pixel value in the middle is what we call our sweet spot. And the sweet spot is handled right here. So it's saying if it's in between the second and the third value, then it will set y direction to 0, so it's going straight out. The ball is going straight. And the x direction is -6 minus mod times 2. So this is a super, super fast ball, and it is very, very hard to return it if the ball is moving faster and if a lot of hits have been done and the other paddle is farther away. It basically rewards it. If you hit really good, you get a reward, and you're going to probably get a point. This was actually included in Tennis for Two. This was a feature that in that game. It was not in the original Pong, if I remember correctly. I could be completely wrong. Correct me in the comments below, or maybe I'll check myself and I'll put it up on screen and call myself stupid. Whichever one. But yeah, that's for the first paddle, and then of course we have the exact same thing for paddle W, which is just the same stuff. So now let's go to ball. Now ball extends Sprite, implements commons. So Sprite is a special thing that we actually have to go to before we get to ball, paddle, and paddle W, because they all extend it. This is an inheritance hierarchy. Sprite just essentially means anything that moves on the screen, which you've probably heard that word before if you play any kind of 2D video game. It's everything that's on a screen that moves is a sprite. So like your characters, your enemies, anything like that. So we have integers, we have x, y, width, and height. We have set x, set y, get width, get height, set height, get height, and then get rect, which is our function that we created. Ooh. So it returns a rectangle with this value, which allows us to use the intersection. So these are all native values that ball has and paddle has. So we don't actually need to state those values because Sprite already has it. So we don't have to recode that in all of these because we know all of them are going to have x and y and width and height values. So anything that they all have in common, they all have under Sprite. So we don't need to repeat the code in 3 different files, which is very, very helpful. But the things that are unique to each one, we have to keep here. So like direction. Here we have a direction. And technically we could put that in Sprite. Direction could go there. And I might check that out as, again, another part of another video. But here we have the direction in the y direction, which is the only one the paddle needs. So we have paddle W, init paddle reset state. Reset state is down here, which sets x and y to the initial place and sets the width and the height. So the height of a paddle is 100, the width is 15, just so you know. Now here is our move function, which I believe is called over here, right? So we call that all the time for all of them. Paddle, so y plus equals dy, so the value of y, which is initialized in Sprite. This is probably very confusing, but this is how coding works. Very fun to have to link everything together and make it all fit. If y is less than 0, then y equals 0. So this means that, this is very important, by the way, if you do not have this, your paddle will go off the top of the screen and disappear forever. And yes, y values, for some reason, start at 0 at the top and more values at the bottom. So it starts at 0 at the top. X is what you would think. It's 0 at the left, right? So if y is less than or equal to 0, then set y to 0. So it cannot go above the screen. Same here. We can't go below the height. For some reason, our stuff still glitched out the bottom of the screen sometimes, and so we added this value, and that fixed it. That's just how you program. You try stuff until it works, and then you don't know why it works exactly, but it does. Now here we have the key pressed. So this is why we created 2 separate paddle and paddle W files. Because here we need to check if paddle W has a W or an S pressed, and paddle needs to check if there's an up or a down pressed. That is the only difference between these 2 files. Otherwise, they are exactly the same. And that should be pretty easy to merge once we try a couple of things. Now, let's go to the last file. The easy one. Whew, almost done. Whew. Go to ball. So ball is a little bit more complicated. It needs to move in both the x and the y direction, and it needs to have an initial value. So as you notice, whenever the game starts, it moves up at a really weird angle, which I decided to do, because why not? And we also have a width and a height, of course. This is using get width and get height, which actually it calls Sprite within itself, which is very interesting. Now here we have the move function, x plus x direction and y plus y direction. This means every time it's drawn, the x value is then set to a different value, and then it is drawn on the screen. So if y is less than 0, here's the side detection. So like how we had side detection in paddle and paddle W, we also have side detection for the ball. So if y is less than 0, set y direction times -1 set y direction to -1 times get y direction. This is very important because we can't just say, like in paddle, that we just set y to 0. That we can't do that because the ball needs to keep moving, and it also needs to preserve its direction. And there's two different directions that it could be moving when it hits the top. It can be at a 45-degree angle or at a, I believe, a 20-degree angle, something like that. No, 45 and a 30, I believe, are the two angles we have. And if we set the y direction to a different value, then if we set it to just 1 or whatever, then it wouldn't work. It would change the angle that the ball hits at, which would be a big no-no. That's not how it works. That's not how an angle works. You don't hit the wall at a 45-degree angle and then leave at a 90. That's not how a wall works. If it's a straight wall and you're coming at it at a 45-degree angle, you're going to bounce off of it at a 45-degree angle, in a perfect world, of course. But here, what we did, which I think is pretty smart, we just flipped it using a negative value. So if it's negative moving upwards, it's going to bounce down and go and do that. Here we have, if y is greater than the height, then it's going to, again, just flip it with a negative value. And of course we have reset state. We have set x direction, set y direction, get x direction. That is confusing. That's how it works. We can then set the x direction and the y direction from board, which is sometimes important because we need to change it right here. We need to change it when it hits the paddle. So that's a very, very important thing. And of course it's moving depending on what the x direction is. So yeah. I will then conclude the video elsewhere, but thanks for watching.